Okay, I'm going to explain how to create the following 2D movements: straight line motion, circular motion and wave motion. So first off, straight line motion. For this question, an object moves in a straight line and at constant speed from the point 2 minus 4 when t equals 0 to the point 12:24 5 seconds later. You first work out the equation of the line, being y equals mx plus c. So to do that you have to find the slope being m, which is 2.8, and that formula is y2 minus y1 over x2 minus x1, as you can see from here. Using that we get 2.8. So the equation of the line is y equals 2.8x minus 9.6. So to add time into this, we must find the slope of the xt and slope of yt using the same formula. So using that, instead of being y2 minus y1 over x2 minus x1, for the x slope it's x2 minus x1 over t2 minus t1, t2 being 5 and t1 being 0, and that gets you mx, and then you do the same for y, and that gets you 5.6, and mx is 2. So the next thing you need is your starting point. So at t0, your starting point on the graph, and they're your kind of starting coordinates. So when t equals 0, x is 2 and y is minus 4. So in this equation we find that it's the slope mx multiplied by t plus the starting position of x being 2, and then for y it's the slope of y 5.6 multiplied by t minus 4, because minus 4 is the starting point, as said in the question. When you put that in and fill out the table, you get this straight line graph showing 2D movement of straight line motion. Okay, for circular motion, using this question here, an object is initially at 7,2 and takes 120 seconds to complete circular motion of radius 4 about a center point of 3,2. You are trying to work out the formula for x equals x being the center point x plus r being radius multiplied by cosine of t being time, and then y equals y being the y point of the center, the y of the center point, plus r being radius by sine times t. So you work out your center point, which is given to you in the question, and you're given the radius, and you also have to work out the speed at which the movement happens, and you're told it takes 120 seconds to do a complete circular motion. So a complete circular motion is 360 degrees, so it does 360 degrees in 120 seconds, so that there is 3 degrees a second. So the parametric equation for this question would be x equals 3 being the center point of x, plus 4 being radius, multiplied by cos of 3t, because it's 3 degrees a second, so it's 3 times faster than normal. So that would be x equals 3 plus 4 times cos 3t, and y equals 2 being again center point y, plus 4 being radius, multiplied by sine of 3t, because it's 3 times faster than standard. And when you plot this into a graph, you get circular motion. To change the radius of your circle, all you have to do is change the number that is multiplied before the cos in both the x and y. Well, in the y it's the number before the sine. So if this is currently at a radius of 4, so if you wanted to change it to a radius of 3, you go in and change this 4 just before the cos to a 3 in both the x and y parts of your graph, you will see that the circle now has a radius of 3 instead of 4. So that's how you change the radius. And just undo this. If you want to change the center point of the circle, which currently has a center point of 3,2, to, let's say, the origin 0, 0, all you do is change the number that appears before at the very start, that's added on. As you can see, it's 3 and 2 currently. If you change that in the equation to, say, again I say 0, 0, put a 0 there and a 0 there, you will see that the circle now is centered around the origin. If you want to change the speed at which it completes its circular motion, all you do is change the number that is multiplied by t inside the cos and the sine. So currently it is 3 times faster than t, which means it's completing it in 120 seconds as opposed to 360 seconds. So if we change that to just 1 in both of these, we should expect it to only complete an arc of 120 degrees, and there you can see that's roughly 100, well, that is exactly 120 degrees of an arc. If you want to switch the direction of a circular motion, all you do is switch the cos and sine in the x and y. Finally, wave type motion. To create wave type motion, I'm just going to use this question tree as an example. So basically only one of your two variables, x or y, needs to be multiplied by either cos, needs to have t multiplied by either cos or sine, while the other one is not. If the other one was multiplied by cos or sine as the opposite, you would get circular motion like this. So as you can see here, this is question 3. This is cos of t and y of t, where y of t is 5t plus 1. So as you can see, your x values are very common cos values that bounce back and forth between 0 or -1 and 1, while your y values are almost constant in their increasing value, and this gives you this here type of wave motion, as you can see in this graph here.